Hello everyone, welcome to Physics online classes for class 11 students. Let us continue chapter 4, Motion in a Plane. Today we are going to study about cross product or vector product. Yes, dear students, you can remember in the previous class we studied what is a dot product or scalar product, and also we have studied the properties of dot product. Remember, when it comes to multiplication of two vectors or product of two vectors, there are three types. When scalar is simply multiplied by vector, so we will get the direct answer, there is no problem. But when vector is multiplied by vector, the result may be scalar or the result may be vector. So we are going to consider product of two vectors in two types. The first one is scalar product and the second one is vector product. Scalar product is also called as dot product and vector product is also called as cross product. Remember, in these two types, we are multiplying two vectors, but the result may be scalar or vector. About the first type, that is dot product, we already studied in detail in the previous class. Now let us learn about the second type, that is vector product, or we can also call it as cross product. Yes, first we have to know what is cross product or vector product. The cross product of two vectors is defined as a vector whose magnitude is equal to the product of magnitudes of two vectors and sine of angle between them. What is the definition of cross product? The cross product of two vectors is defined as a vector whose magnitude is equal to, its magnitude is equal to product of magnitude of two vectors and sine of angle between them. Remember, in a scalar product we used trigonometric function cosine, but here we are going to use the function sine. Maybe you have the doubt like why we have to use cosine function in dot product and sine function in cross product. In a simple way, you can remember these are the suitable functions. First point. And the second point, these functions make the formula very simple. It makes the calculation very easy. The next point, when it comes to cross product, here we are using the function sine because the primary purpose of this cross product is to calculate the area. When we are going to calculate area, so we are going to use this cross product or vector product. Here this is basically just like the area of the parallelogram. You can understand it later, but it is the area of parallelogram. Area of parallelogram is equal to cross product or vector product. So here the suitable function is sine. So we are using the trigonometric function sine here. When it comes to dot product, the cosine function is suitable. Right? So why we are using sine function? So how it will be the area of parallelogram, that you can study in the properties. Now let us understand the definition. The cross product or vector product is a vector whose magnitude is equal to product of the magnitude and the sine of angle between them. Observe the equation here. If theta is angle between the vectors A and B, then their cross product is given by the equation. This equation is very important, equation 1. Observe here. Cross product, when you are going to multiply two vectors, if the result is a vector quantity, then it is called a vector product or cross product and it is denoted by the symbol cross. How to read here? Don't read as A into B. What is this? A cross B. When it comes to scalar product, we have to read as A dot B. But here A cross B, right? Vector A cross vector B is equal to AB sin theta into n cap. There is a new term here. Observe, I am going to consider two vectors. Vector A cross vector B is equal to, according to the definition, this is a vector which is equal to the product of magnitude of two vectors. Magnitude means mod of vector A mod of vector B. The product of magnitude of two vectors and sine of angle between them. Angle between them, let us take it as theta. Mod of vector A into mod of vector B into sine theta. This is the expression. But here, mod of vector A, mod of vector B into sine theta, this gives only magnitude. But remember, this is a vector multiplied with another vector. Answer should be what? Answer is also vector quantity. Vector quantity is having both magnitude and direction. So here, mod of vector A, mod of vector B into sine theta, it gives only magnitude. We want direction. Generally, directions are given by unit vectors. So in general, the direction is denoted by n cap. Is it clear? So n cap is a unit vector that gives direction because the resultant is a vector quantity. It is having both magnitude and direction. Magnitude is given by mod A into mod B into sine theta, and direction is given by n cap, and this is a unit vector. Is it clear? Or this equation can be written as vector A cross vector B equal to mod of vector A is what? A. Mod of vector B is B. This is what? Magnitude. AB sine theta into n cap. Or you can write this equation. Right? This is the final expression for cross product. If you want only magnitude, no direction, then so we can write equation 2 here. Magnitude is mod of vector A into vector B is equal to AB sine theta. Not necessary to write n cap. Whenever you are going to write n cap, that shows direction. If you want only magnitude, then you can neglect n cap. Where n cap is unit vector. This unit vector is perpendicular to the plane of vector A and vector B. I will explain how the unit vector is perpendicular to the plane. Yes, before that you can observe the note point here. Cross product of two vectors gives a vector quantity. Vector quantity means it is having both magnitude and direction. Magnitude is AB sine theta. Direction is given by n cap. Now the question arises, how to represent direction in a coordinate system? Yes, see here. Let us consider two vectors. This is vector A and this is another vector B. Angle between these two vectors is theta. Theta is angle between them. Now, the resultant is also vector quantity. We want direction. Magnitude means normally we can write A, B, sine theta. We will get the answer. What about direction? When it comes to direction, remember tail of the first vector, tail of the second vector, they joined at this point. At this point, I am going to use two rules to find the direction of the resultant value. We are going to use two rules. The first one is we can use right thumb rule and the second one is screw rule. So we can use two rules to find the direction. The first one is right hand thumb rule and the second one is screw rule. Right hand thumb rule and the second one is screw rule. Yes, how to find the direction? Now let us observe the first rule. The first rule is what? Right hand thumb rule. Listen here carefully. At the point O, let us take this is the point O, where tail of both the vectors are going to join or they are going to meet. At this tail, yes, now I will explain about the first rule. So vector A cross vector B, I want this value. Vector A cross vector B is equal to magnitude means we can write mod of vector A into mod of vector B into sine theta. This gives magnitude. What about direction? Whether the direction is upward or downward or inward or outward, that we have to find. I am going to use first rule. So we have to move our right hand from vector A to vector B. Listen here carefully. Take your right hand and just fold your fingers from right to left. That is from vector A to vector B. When you rotate or when you fold your fingers, right hand fingers, when you are going to fold it from vector A to vector B, when it moves from vector A to vector B, where is your thumb? Thumb shows in the upward direction. Practically you can use your right hand and do it. So take your right hand and just keep it on vector A. Remember, vector A and vector B, this is on the plane surface. On that plane surface, we consider two vectors. When you are going to move your right hand fingers, so just open your thumb, move your remaining four fingers from vector A to vector B. Just move it. When you move your remaining four fingers, your thumb gives the upward direction. Right? When your thumb shows upward direction, that is the direction of your vector. So now I can draw here. The direction is upward. Remember, the direction is always upward or that may be downward. Always the direction is perpendicular to these two vectors. Is it clear? So now when you are going to use the first right hand thumb rule, just fold your all the four fingers from A to B. When you move your four fingers from A to B, your thumb is in the upward direction and that gives the direction, and this direction vector or this line is always perpendicular to these two vectors. Observe here. This line is perpendicular to both the vectors. Yes, that gives the direction. So we can write vector A cross vector B equal to mod A mod B sine theta, and its direction is upward. Is it clear? Suppose if I am going to find the value of vector B cross vector A, whether the direction changes or that remains constant. Observe here, vector B cross vector A. So magnitude means directly I can write mod of vector B, mod of vector A, sine theta. Easily we can write this one. What about direction? Yes, again I am going to use the first rule, right hand thumb rule. We have to move our right hand fingers, right, from B to A, not from A to B. We have to move it from vector B to vector A. How to move here? We have two chances. One is having the smallest angle. We can take in this direction or we can take outward angle. Remember, always we have to consider the smallest angle, right? So here the outward angle is bigger. So don't take this angle. Let us move your right hand from B to A. Just open your thumb. Again use your right hand. So just open your thumb. So you should move your hand from vector B to vector A. Where is your thumb? Thumb is in the downward direction. So here we can write vector B cross vector A is in the downward direction. Anyhow, the direction is always perpendicular to the plane of vector A and B, and this is always represented by unit vector, and this is denoted by n cap. Is it clear? So this is all about the first rule. If the first rule is comfortable, you can use it, or you can go to the second rule, screw rule. Screw rule, here observe, at this point means where the tail of the first vector and the tail of the second vector, where they are going to meet. Let us take this is point O. At this point, at point O, I am going to keep a screw. We have to keep the screw at this joining point. Screw rule. I want vector A cross vector B. When you are moving your screw from vector A to vector B in anti-clockwise direction, just keep that screw at that point O and move that screw in the anti-clockwise direction, means from A to B. Your screw will come in the upward direction. It will come outward. Suppose If you are moving from vector B to vector A in the clockwise direction, then your screw will move downward or inward. Right? Either you can use a screw rule or right hand thumb rule that gives the direction, and the direction is always perpendicular to these two vectors, and it is denoted by unit vector n cap. Is it clear? So what is cross product? Cross product of two vectors is a vector whose magnitude is equal to product of magnitude of two vectors and sine of angle between them. And it is given by the expression vector A cross vector B equal to AB sine theta into n cap. AB sine theta gives magnitude, n cap gives direction.